to speak. Welcome, everybody. Welcome to this this session of the Research Data Architectures for Research Institutions interest group, RDA for short. Thank you, Vila. That was a lovely acronym you created, and we're carrying it forward. So this interest group's focused very much on the architectures that exist within research institutions. So it's not specifically focused on one discipline, it's rather focused on the challenges that exist within research institutions. So I'm joined today by James Wilson, and who's going to be taking over from me in a second, I hope, and Rory, my fellow co-chair. So the three of us are puzzling about these challenges, and every time we're picking off a different topic that's related to the challenges that exist in research institutions related to research data. So I would now like to hand over to James for the key challenges related to the retention and disposal. Thank you all.
Thanks, Keith. Sorry about that, everyone. Right, okay, so where is the clicker? This must be the clicker here. Okay, so here's the agenda for today. So we've got two speakers lined up who are going to be talking about what they are doing, what they're planning regarding the retention of data. Then we'll have a general kind of, hopefully an interesting conversation where everyone can explain what they're doing at their institutions, where they're working, what kind of approaches they're taking to data retention, talking a little bit about the sort of policies, infrastructure, and other things that they hope might address some of the challenges. Before we carry on, I think Keith may have just given apologies for being slow, I think Keith may have just run through this, but essentially what the RDA group is it's a group that looks at architectures in research institutions. It's primarily concerned with technical architectures, however, it is also very interested in the kind of context in which those technical architectures are developed. So it is very much interested in also the people architecture, who does what, the roles that people have, and the kind of policies and governance that sit around the core technical architectures. So it's, whilst I think it says on here, it's a bit about the nuts and bolts of things, it's actually a little bit broader than that, because context is so important, not just context around data, but the context around data infrastructure. So we've identified a number of key challenges that we're hoping that this session will address. Perhaps the most obvious one, particularly for those of you who, like me, work in a fairly large kind of institution and have to be answerable to senior management when it comes to spending money or wasting money, as it can sometimes look, on a Sisyphean task of dealing with ever increasing data growth. The costs of data are undoubtedly growing. A lot of senior people, certainly at UCL where I work, are a bit concerned that there's no end in sight of the growing costs. The costs of curation also need to be borne in mind, so that is a big challenge. Deriving from that is those kind of technical layers and how we at least can minimize the costs of data retention, data sharing, what we can do in terms of tiering data, tiering infrastructure, archiving data, deleting data. We're going to be hopefully talking a little bit about some of the challenges that come from different disciplines. Different disciplines, certainly in my experience, have very different attitudes towards the data they gather, what needs to be retained, what can be removed. They don't necessarily all come from the same kind of position. Something that's common across a lot of disciplines is the kind of keep everything mentality. If you want to ask a researcher what can be deleted, the chances they won't come up with very much. If you ask them, I mean, one of the situations that I'm in at the moment is we have our Institute of Neurology who are moving buildings. So they need to move all of their old local data storage, all of their NAS drives out of the old building. They've been told they can't bring them into the new building. They have to use central services, which is great, but they have data that dates back 10, 12 years. The PI of the project may have left the institution. Nobody knows what the data is, but none of it can be thrown away. It must all be kept. Even though no one knows what's there, there's no descriptive metadata around it. No one could ever possibly really find it to reuse it, but everything must be kept. Predicting long-term value. So even when you do know a bit about the data you've got, how do you actually know which of that data is really going to be useful sort of 10, 20 years from now? What's really got the long-term value? Documentation to inform retention. Often a lot of the data that we have that's been collected by the departments don't necessarily have much documentation around them. So it is very hard for anyone apart from the PI who originally did it, or sometimes just a postdoc who put the data together, to really know what it is. Policies, politics, who's got an interest in this, that, and the other, what the policies are. Are they good policies? Are there ways in which we can improve policies regarding retention? And finally, because this is 2023, we have to discuss artificial intelligence and the role that artificial intelligence might have in data retention. Certainly, human intelligence hasn't got us terribly far. At UCL, we've done a bit of work to identify what data, the kind of patterns of data usage. So people will generate data, they will put it in the central services that we offer, and then it might just sit there for about 2 years with nobody accessing it at all. And suddenly there's a huge burst of activity as people move on to a different phase of their research, and there's a lot of access. So it's not easy to spot patterns and work out exactly when you can delete data because it's not being used, because all of a sudden it can get used an awful lot. So can AI help us out with this? And I think at this point, yes, those are the discussion topics for later. I think at this point, we will move to our first speaker. Now, let me see if I can actually get the right slides up. You'll do that. Brilliant. Okay, excellent. Let's go back then to the... Luke's up first. Okay, brilliant. Yeah, if you can... Luke, do you want to take over and introduce yourself?
Hi, colleagues. Good morning. G'day from Australia. Lovely to be here in Salzburg with all of you. I work for the University of New South Wales in Sydney in Australia, which is a large research university. I'm presenting some work that we've done with some colleagues across the sector, and some of the authors of our work are here in the room, so they'll keep me honest, I'm sure. We acknowledge country in Australia, and we acknowledge our First Nations on whose unceded territories a lot of this work took place. I want to thank Keith for the invitation to join a group where I feel very much at home, given the bullet points that I saw, and hopefully a few of the items from today's presentation will start the conversation going in the room. That's the aim of it. I've thrown a lot of slides in there, and some I'm just going to slide through, but I've included all the material there so you can kind of see our working, and maybe there's a few things in there that might pique your interest for a little conversation over morning tea. I'd like to thank the Australian Research Data Commons, the ARDC. Keith works for the ARDC, but that was the group that helped pull us together through a program called Institutional Underpinnings, which brought several groups that wanted to focus on a number of important issues relating to our institutions, as well as some of the big national agenda topics that the ARDC is undertaking. And so this piece of work around data retention was particularly important to a large group of us in Australia. And so we put together a couple of projects that were intertwined, and I'll speak a little bit about that process. And so, again, I'll thank colleagues not present and the institutions and organisations that were part of this type of work that you'll see today, and work that we hope will continue. The presentation is really around two projects. As James so well said, it's that problem of data growth that we're facing institutionally and across the sector in Australia that we're responding to. But we realised very quickly that without actually being able to count it and agreeing on what we were counting and making some reasonable assumptions about what we had, being able to decide whether we should keep it or not was pretty difficult. And so that process of deciding what it is that we have, and is it valuable, who's it valuable to, is part of the efforts of this project. We did a very first pass through our policy landscape, the rules and regulations under which we operate. That was pretty easy to do. It was just a paper effort of going through all the rules and regulations, and then putting that against our state institutions, some in New South Wales where I work, some in Victoria where Eileen works at the moment. Those different rules are slightly different across the states in Australia, but by and large, the rules around retention are fairly standard and fairly international in their practice. I have 7 petabytes of basically cold, dead data in an institutional data archive. I'd like to push the delete button. The rules mostly say that I can, as long as it's not research data. But what's actually research data, and most of the stuff in my archive is stuff that's come off instruments, stuff that researchers have created, but is it the output? Is it the research work? And so those types of conversation have been important to us. Again, colleagues in the room, Eileen and Reese and Claire, have done some work that we're presenting later on in the week, where we've tried to count how much research data we have in Australia and how quickly that's growing. And so I'll use my little privilege of being up here in front of you and encourage you to come along to those talks as well. So we started doing some work. We found that we could report about the systems in the institutions that were holding data. That just took people looking at numbers on screens and working out whether that was the single copy or duplicate copies and other work around that. But we found that we had some ability to report about the contents, about the holdings, about the systems, but not about the content, about the actual files that were in those systems, and that there was no really nationalized or commonly held definition of what research data is in Australia. So, as with some of the work done by RDA and internationally, what were the properties of data that we institutionally in Australia might be interested in really assigning to these inside these systems? Again, you wouldn't be surprised by some of the bullet points up there on the screen. What we then did was we tried to figure out in the institutions that were taking part in the project whether they had those types of information about the data in their systems or not. And some did and some didn't, and we did a little bit of talking to one another about the contents of our systems. We, as many before us have done, fell into the deep, dark morass of taxonomy. And we said, what is the value actually of doing this? And there is some value. And especially as we maybe head towards machine actionable systems and machine actionable processes, the taxonomies become even more important. But the work of the project team was really to start, producing some reports and finding out what we actually had in some of our systems. And with the definitions that we'd agreed to actually start reporting that to ourselves, if to nobody else, because we were the ones that cared. And so we said, why shouldn't we just start reporting to ourselves? And so we started doing that piece of work. But the automation, the manual work that it took to do this, to get these numbers out of these systems, was hard, and it's not automated. So we have numbers for some of the definitions that we agreed to collect, and we kept doing the work, and we published some of this finding across the institutions that were involved in this project. And these are some findings that might be of interest to you. That regular reports on the state of research data as an asset don't exist, but information on the state of storage can be done. Systems in place to store the research data don't themselves contain the information on those properties. That's pretty obvious. A best practice means of collecting such information is not in place across our institutions. And it's difficult at the moment for institutions to automate this, but we're going to slowly make progress in that direction, we think. So we did some work on validating our findings, and I'll skip over that briefly. But of real interest to this group, this practice of retention and disposal of research data. Should I delete my 7 petabytes of pretty cold, pretty unused? Nobody's really going back and searching inside those data. So my institution's paying about $25,000 per month to store those data. That's, we could do some other things with that money. And so should I hit the big red delete button? We think that one of our contributions that might be of interest, at least to further discussion by groups like this, is to maybe unspiral the data lifecycle. We're really frustrated with the data lifecycle as a picture and kept looping back around. We thought that unfolding it and seeing where data decisions take place across the lifecycle could be useful in terms of practice change both for the researcher, practice change for the institution, and also for automation opportunities. And so really mapping out across the life cycle where operational opportunities for metadata enrichment or data disposal decision-making points might take place. And so this part of and this is not a perfect, it's only 3 workshops and contributions by a number of Australian institutions. So we're here presenting it to be open under a bit more scrutiny internationally. But these stages, we think, have got some opportunities for taking some actions according to the working groups that we've been a part of. So where might we be able to do some data deletion points, especially if we started automating those activities? So operationalizing decision points, really working towards data having value. In my HPC world, we have a well-recognized practice of having scratch file storage, and being able to get rid of that scratch file storage is totally allowed by the instrument controllers at certain points in time. And it's really that practice of curating for the researchers, flushing some of that big instrument data, the HPC data, is fairly traditional in our circles. But that's the data that I have in my archive. A lot of that raw debris, uncurated, no metadata data. And so we want to improve the flows and the decision points to trigger having more metadata so that we can make better decisions. So we've identified some of the best, what we think initially, at least in Australia, as some of the best opportunities for taking action. Big red boxes around those when I haven't tested that yet, but that's what the group thinks. And so that's the work that we've done. We sat in a room start of last week to start doing some activities to really say, how should we, operationalize some of these decision points? So that's the update from those projects. And again, thanks to those participants, and thank you for your interest.
Thanks very much, Luke. Yeah, I think we've got a kind of question and answer session scheduled in after both speakers have spoken. So I might summon the 2 of you back up to take some direct questions, and then we'll do a broader discussion. So Fabian, do you want to come up and introduce yourself? We have the slides magically appeared. Thanks.
Yeah, great. Good morning, everyone, from my side. Welcome to the report, how data retention and disposal works in our single medium-sized institute. So, in opposite to Luke's talk, I will show how it is possible only for our institute, the Fritz Lippmann Institute on Aging. The short name is FLI. And how can I go to the next slide? Yes, okay. Yeah, we are located in Jena. So this is in Thuringia, in the middle of Germany, and our institute is focusing on biomedical research on human aging as a process controlled by genetic and environmental factors. So I work in a group which is responsible for maintaining an HPC and up to offering seminars for good scientific practice. Yeah, and the challenges we had can be divided into 3 levels. And yesterday I attended a talk from a person from the Princeton University, and the slide was similar as the same. So there are 3 levels, as it is so often. There's a technical level. So we had to find hardware, so the right hardware solution with hard disk, solid state disk, and tapes, and so far. And then the software layer, where the user interacts with. So I mean the software on a higher level, and of course the organizational level, where we have to involve all the scientists, because the way of work changes. The user have to annotate data, have to create metadata, and to use new systems. As I started in 2018, we had a network file storage, as it is so common. So every group had their space there and saved their files on a group share. And then over time, of course, the group will be closed. And then the question was, what the hell to do with the files there? Yeah. And there, 2018, we introduced an electronic NAP notebook. So it was mandatory to use, and it is still. It was the second place we had in the institute to save scientific files. But the electronic lab notebook is not designed to add metadata to specific files. And it's also not, it cannot handle large files. So we had the problem to find a solution to work with large files and to annotate files. Yeah, first, we searched for a hardware solution, and we decided for a hierarchical storage management system. It is a system where the files move from time to time from cost-intensive fast storage to low-cost storage to tape. So it saves money for us, because in our experience, files will be not touched after some months. And so it's fine for us that the files will remain on tape only. So we installed hardware, 400 terabytes of hard disk and 3 petabytes of tape storage. As we bought the system, our neighboring institute, the HKI, had the same idea, and they bought the same system. This was the opportunity to connect both systems so that we have a backup system. Every file will be synced with the system at the neighboring institute, so that we have a backup if we have a disaster in our server rooms, like fire or water impact, so that we are safe, because we want to save important files on the system. Yeah, and this was the reason for the secure system. Then the second level is the software layer. We searched for a system where we can add metadata, and we found iRods as a data management system, which is widely used and where metadata are deeply anchored. And the system gives us further the opportunity to define rules how to process data. It is for us a framework. It gives us the main functionality. And on top of iRods, we use Yoda. Yoda is a system developed by the University of Utrecht, and it uses and it expands the iRods functionality. It gives us or Yoda defines metadata forms where the user enters the metadata information. And it is the user interface. And Yoda also defines process, how to move files into a vault or how to freeze files. And with this process, the user gets stable links, which can be used later to connect the systems with the inside the EOM. Yeah, this is a screenshot from our system. Here you can see files from a sequencing run. So there are 6 files. The first 5 files are the data from the sequencing run, and then we have 6 file called Yoda metadata. There is a metadata saved, and the metadata are connected to a collection. So the user don't enter for every file the metadata, they enter it for a collection. And this is, in this case, all files from one sequencing run. And this is how the metadata form looks like. So we have some mandatory fields, like you see here with the star on the fields. So the user have to enter title, version, run date, and so far. And also there are some optional fields. And if the user like to move the file, the collection to the vault, the user have to enter the mandatory fields. And the metadata form differs from use case. So before we include a group into the system, we get in discussion with the group which files you will save inside the system and which metadata forms, which metadata we have to include into the metadata form, and which fields are mandatory and which fields are not. So the metadata form differs from the use case. But we have some mandatory fields for all use cases. This is the title, this is the version, and this is a retention period. So we have a standard of a retention period. This is 10 years, but we can adapt it to the use case, and the user can adapt it for every collection. Yeah, Yoda has also some important metadata fields like description, data classification, and license. And these files are, or these information are important if we use the system as a repository. So, okay. It is possible to use Yoda to publish metadata information and the files too. Yeah, now we have the hardware, we have the software layer, and now maybe the biggest challenge is the organizational level. We have a data steward to accompany the new process. So the data steward get in contact with the scientist, defines new rules for data disposal, for good scientific practice, for archiving, and engage and convince the employees to use the system. And from previous talks from yesterday, I heard it. So an optional use of the system will not work, and we have to create some pressure to the users. So the pressure will be that we will delete in future all the files saved on the network file storage if they don't use the system, the archiving system, and to annotate the files and to enter the retention period. Yeah, thank you. Thank you to the interest group, to Rory for the invitation. And to my group. Thank you.
Thank you very much to both of the speakers there. A lot of interesting issues raised, and at least some good movements towards solving some of the issues that we discussed in the introduction as well. I think we'll start off by taking some questions specifically for the speakers, if we have any. So do we have a roaming microphone that we can... There's two of them, excellent. So Keith, if you want to take the mic, as it were. With the microphones, I guess, and I'll just swap up here. Questions from the audience.
Thank you very much for the interesting talks. I have a question specifically to Fabian. So, as I understood, the interface from the tool Yoda is the main interface for the common scientist to come in touch with all this stuff.
Yes, yes.
So you mentioned that there are several fields, some of them mandatory, others not. Are any of the fields, mandatory or not, automatically filled from other systems? And if so, which systems?
Yes, it's a good question. We started with some groups, and we started with a easy use case where we can create scripts and to import files automatically and to import the metadata automatically. This was the starting point, and now we come to the more challenging use cases where the user has to create the metadata information more and more. Yeah, so it's possible to create automatically metadata information, but until now, no, or not. So in the next time, the user has to create more and more manually work.
Yeah. Hi, my name is Hagar. I'm from the Joint Research Center of the European Commission, and not familiar with the interest group. Maybe this is a silly question, but I haven't heard you mention how if you treat retention of metadata differently than that of the data. I imagine you do, but just to make sure. And also if there's a consideration in terms of accessible, so basically online storage, and backup storage that's not readily accessible, if that was a consideration you looked into.
From my institutional perspective, we do treat them differently, and I have no problems keeping large amounts of metadata for a long time. It's such lightweight compared to the rest of our content, and there's probably some useful information in that metadata. So.
Yeah, in our case, in Yoda, the metadata are deeply connected with the collection, so they are strongly connected inside the system.
And I think there was also a question about open, whether open makes a difference or not. Is that correct? That was your second part of your question.
Yeah, open makes a huge difference for us. So as soon as it's in a repository or it's outside in a discipline-based repository or institutional repository, it's treated very differently with quite different rules. So those parts of our data collections, I'm less stressed about that from a retention perspective. We've got full commitment on keeping those open.
And for Fabian, what's your perspective there?
Yeah, so the user can publish metadata. Was this the question? So there's a process defined in Yoda where the user can publish metadata. So there can be a data steward to check the publishing process, and if it's all okay with the files, then the user can publish the metadata.
Thank you. And Mark, your question?
Yes, Mark van der Zanden from SURF. Just a follow-up on that question, because you mentioned that, okay, just for us easy to maintain the metadata for long term compared to maybe the data. Do you then also generate tombstones for the data?
Not yet. I haven't hit the big delete button on big chunks, but we will. So we've got that. The database is separate from the storage. And so once I purge data, we'll create end of life statements for those particular attributes or particular objects. But yeah, what would be more interesting is where we've got stronger backlinks back in from open back into those collections. And some work that we've done suggests we're only able across our 6 petabytes. Eileen, do you remember what number in total terabytes we found? Eileen just left. That's all right. So it's hundreds of terabytes across petabytes. So a very small percentage.
Also another question. Certainly, if you want to remove the data, who decides on this? Is this you? Is this the researcher? Or how do you look beyond the use of the data, beyond the original user of or the researcher who generates the data?
Who pays? Should decide, maybe. I don't know. I think the first group, no CI, can be found. Are we fairly happy to get rid of that? Is it only data archaeologists that care about that? And I'm left paying the bill for that future data archaeologist. So that's where we're grappling. Nobody in my institution has allowed me yet to hit the big red button for some of those reasons. But at the moment, my question back to them is we're paying for the post-research cycle. So the students that come into our institution are carrying the costs for our research funders. So that there's an equity issue there in our national conversation that we have. So our institutions are paid to do research by our funders. That's fine. We don't mind that part. Part of that maybe is there for retention purposes. Maybe, mostly it's there for doing the work. The institution then pays for the next 15, 20 years.
Okay, but then you have policies that data at least should be maintained for a certain amount of years. Because I think in the Netherlands, there is a guideline of at least 10 years.
Yeah, thank you, politicians.
Okay.
It's a good conversation to have. So do I hand it over to my state library? It's not my job as an institution. It's legally my job, but only if it's research data, not if it's the files that are not. If I call it not research data, can I then hit them?
Okay, we started with Yoda 2 years ago, and we have not the case that we have to delete files. There is no automatism. We are a small institute, so in some years we can check which files are end of life, and if the group still exists, we can ask, okay, we will delete now these files. Is it okay for you? Maybe this will how it will work.
Before we go back, is there any questions online, Rory, that you want to... Oh, okay. Oh, fine, okay.
Yeah, I'm a bit puzzled by the very peculiar term research data, because this obviously externalizes major decisions to whoever seems fit to decide at what point data becomes research data. And well, in our practice, everything that is created by a research institution is first and foremost research data. Otherwise, we'll have a problem taking this distinction. So I'm pretty happy we don't have this difference here. At what point came this distinction into life, or this differentiation into life, and what were the professionals' opinions about this?
Yeah, that's the conversation that we're having internally at the moment. So the practitioners, the researchers, if a researcher says it's research data, I'm happy to believe them. The scratch files on my HPC system don't get treated often like research data. They get treated as analysis files through the process. And then the code of conduct says it's research data if the researcher says it's research data. If they don't say it's research data, am I allowed to interpret? That's the internal conversations we're having. So I believe your line is a strong one. It's a clean line. But once there's no actor, no chief investigator, nobody claiming that data, I think I'm allowed to do what I want with it.
Yeah, I agree fully with Luke's.
So we make a distinction between research data and non-research data, which sometimes gets called enterprise data, although that's a complete misnomer. So anything relating to kind of teaching or lecture lists, reading lists, or anything like that, we don't regard that as research data, but there is no real definition. Nowhere is it actually written down. So again, I think like most institutions, if a researcher says it's research data, we take them at face value, and that's the way we treat it, because we just don't have the time or resources to in ourselves inspect every bit of data that people are generating. So we just have to take the word for it.
So I think Rory was next, and then Andrew. Yeah.
Yeah. So we kind of, this is interesting. We got a very kind of high level view from Luke of a project which involves multiple universities looking at investigation and policies, and then a very specific presentation of an actual implementation at a particular institute at the FLI. This is actually a question for Luke, and I realize you don't have that much time to go into it, but in terms of the various universities that are involved in your project, and they're probably a lot bigger than the FLI, could you give us some sense of kind of maturity in terms of, I mean, there's a very specific solution in place now, or being put in place at the FLI. Kind of what stage are some of your institutions involved at in that process, would you say?
One of our 8 universities has deleted 1 petabyte deliberately, with forethought and care, and identifying that it wasn't going to hurt or do anything bad to the institution or those things. So that practice is still not automated, not enacted yet, but the group is starting to think about that, the impact of the cost if it keeps growing, if there is a net cost to the universities as a sector, and then what's the job of the sector in the retention practice nationally, and will the funders recognize that there's a cost to that? And then, so I think we're preparing an argument nationally by counting and by saying, here are the rules, and we're all clear now on the rules. And this is the emerging best practice by the practitioners who are data custodians, responsible data owners. And then, so I think there's a high level of maturity that's growing in the decision space, but we haven't triggered any of that process yet.
We're running on, move on to the next step. We'll take one more question.
Thank you, Andrew Trelaw, Australian Research Data Commons. So, question for you, Luke. I very much like the idea of digital debris or research debris. I think this is an area that we need to think about a little bit more. So I have a 2-part question. So I guess the first part is, how do you deal with the issue where someone's debris could be someone else's valuable research data? And a more difficult question, for which I'm happy for you to hand wave, do you have any sense of the relative percentage of valuable research data versus research debris?
Yeah. The second part might be where we've got a little bit of interest. So we've looked at the number by collections that's in open versus the number that's in the data stores. Eileen, do you have that off the top of your head?
Hello, everyone. In terms of openly discoverable, there's about 80 petabytes in Australia.
Out
And
of 370.
pardon?
Out-
Of 370, correct. And the majority of that, it would be data that's held by communities that already have established practices around sharing, specifically in Australia, that's predominantly astronomy. So that's almost that's about 60 petabytes last year that they have. In terms of universities then, the biggest universities in Australia, they have they have quite a bit less than 1% of their data stores in their institutional repositories. And in terms of their external repositories, we weren't able to measure that, but that's probably a good indicator of in the stores how much is actually potentially research data because it has a DOI on it. And then a separate ARDC project, the data retention also kind of indicates the same sort of trends in terms of our collections don't necessarily represent research data. Researchers will only pick out 1 or 2 files. And so that's probably a fairly accurate representation at the moment.
And to the first part, I'll say again, deliberately being poking and deliberately being provocative, who pays? I'm very happy for somebody to have an interest in my data and be an active participant in curating it, or an AI process to trawl it. If I have a reward metric, a citation metric, a money metric, I don't care, but it has to be usable by something, somebody, somehow, somewhen. I'm not going to keep useless stuff forever. And so the hypothetical data archaeologist, I'm very happy to assign that of mental value. But at the moment, we're getting to the edge where we have to have those conversations.
Brilliant. I think we should move on to the next stage of the conversation, but I'd like to thank again the 2 speakers. And we have the discussion topics up here, but not up there. If we could just bring up the discussion topics. I mean, to be honest, I think we've all got a pretty good idea of what we want to discuss probably after that anyway, and some of the issues that we've covered. But we'll bring up the slides, and I will swap over with Keith. I think Keith can.
Yeah, if you could
compare.
bring up there we are. Wonderful. Thank you very much. Yeah.
Oh, yes, that's the Roman mic.
So, well, first of all, big thank you to Luke and Fabian for the presentations. I think that really set the scene quite nicely, and some of the topics were already coming up, both in the presentations, but also in those questions. So as we were trying to unpack retention and disposal and what are the challenges that you run up against, we managed we came up with a few of these key topics, a few angles that we thought probably would resonate, and we'd be interested in hearing your thoughts from the audience and also from our virtual participants. So working down from the top, what do you see as key criteria for retention of data? What is the thing that's going to make a difference? Why would you keep research data? So any thoughts on that one? Andrew at the front there.
So who's the you? You, the researcher, you, the institution, you, the country, you, the research funder? Because the answer is going to be different for each of those.
Luke's diving deep into his phone. I think it's a good one to pass on to Luke. James?
Citation has a value that we mostly all understand. So if it can be cited and has that fairness to it, most of the actors in the chain will recognize, will assign some value to that, and probably be quite active in saying that looks like something good and we should keep it and do everything we can to try to keep it. The less fair, the less value, the less citability.
Okay, I think Mark raised his hand up here.
I think use and reuse. So you have to measure what is the use and what is the reuse of the data. And so if there is actual use and reuse, and I think that is somewhat related also to citation, because there you can see, okay, it has been reused because you see it from other citations that it has been reused. But the other problem is if you want to then measure how many times should it be cited, I'm not sure. How do you differ between large research areas and small research areas? That's also will differ, because if you have only a small group, then it will not be cited that much or that many times. So how do you measure this? I think that will be probably more the difficult areas. How do you want to put numbers on this so that you can create criteria?
Hi, Yan Wang from Delft University of Technology. Besides the user perspective, besides the infrastructure perspective, we also received the requirement for intention from like our colleagues who do archives. So they have to follow the archive law. We got conflicting guidelines earlier between the privacy team and the archive colleagues, because for privacy reason, you need to have certain retention periods required or not required. But for from archive perspective, they said this is organizational responsibility, that if you are being audited or assessed, then the organization should be able to reconstruct activities that you conducted, basically meaning that you should keep all the data in case that you are being checked. So we have to follow because it's law, but we find that's very problematic in reality when we advise to researchers or to colleagues in the infrastructure. Well, what should we do? But that's from our perspective, that's definitely one criteria we need to consider, but it's from different perspective.
Okay, thanks. I think I saw a hand over there.
Nearest first.
So, hello, I'm Lars Eklund. I'm from Uppsala University in Sweden, and the HPC system there. I think, again, as previous speakers here, if we look at citation only, we will be in quite a lot of trouble with high value data that is not cited much because the field is small rather than so it's very hard to use that as a deterministic factor. And we also have, as the previous discussion here was with the legislative problem, where you have both the archive laws but also the laws of data minimization. So in Europe, if you're working with sensitive data, you need to minimize the amount of data that's actually stored. Mm-hmm. And this is quite complicated, I think. So I don't really have a good sort of explanation here, and the question was sort of that I want to put is that because we tend to get loaded with sort of, because the institutions that we serve, they tend to kind of stick their head in the sand because they don't want to deal with this issue. So the data gets stranded. So we have lots of stranded data that we can't really delete with a good ethical consciousness, but it's really also hard to keep it. So how do the rest of you handle this issue? I think is quite interesting to hear.
Good morning, Ville Ten. I'm from University of Helsinki at this moment. After this meeting, I'm from EGA Foundation. In the Helsinki, we have this kind of project called research data long-term storing, not preservation, storing. It's a little bit like a retention. I don't know the gameplay of this word. We have thought about this criteria, and it's a pretty complicated question actually, and we have how can I say, outsourced this question from the project to faculties, and we have a few petabyte storage capacity, and we are sharing them to 11 faculties by total budget of the faculties, and then we have some quota for every faculty. And then there is this kind of committees in every faculty, and we have said that, okay, it's your job to make this assessment. What is the scientifically remarkable data? What you would like to store or save for long term. Long term is 15 years in our perspective, not like that, because we have to put some years there. So we are outsourcing there, and they are making this kind of scientific assessment, because we are not able to do that, because we can't handle that. Okay, there is no perfect solution, but we have some solution to share these capacities, resources, and making some kind of decision system and so on. Of course, there is some multiple other small questions, but we have solved this one.
Okay, thank you.
Someone who works in central services, that sounds like an excellent way of solving the problem.
I'd like to move on to the question of infrastructure technology. In the two presentations, you saw Fabian's example was quite distinct, and for a distinct institute. Luke was dealing with a much broader institution, university as a whole. I'd be intrigued, does that technical and quite specific approach within one institute translate to an institution as a whole? Are there lessons learned there we can take from the technology that Fabian's been using and developing or implementing? Does that translate to an institution? First of all, I'd like to throw that to Luke, but I'd also be interested in, I'll bet there's other people in this audience that are thinking at that broader institutional level too.
You want to give me a version 2 of that, like say it a slightly different way?
So looking at Fabian's, looking at the presentation, that was quite a distinct technological solution.
Right.
As you were watching that, did you think, yeah, that would work for me? Or were you going, nah, that will never fly at the whole of a university level?
No. So yes, good metadata tools work. We know that at scale, and they work. So we have good examples in Australia where storage is tightly integrated with the metadata systems. Fabian's example at an institutional cross-discipline university scale. University of Queensland in Australia's probably leading in that space. University of Sydney does a really good job of it as well. So that tight coupling of a good RDM style, my project information at a high level with machine actionable content, adding to richness through the systems. This data was generated by HPC on this date by this person. This instrument generated this data on this date. So, and you package it up and it tiers up and you search it. So that aggregation point of tool plus user metadata in an institutional repository does work. The experience at my university with our large data archive, which also has reasonably good metadata that I can query to say how hot and cold the search is of that. So my active system is not well integrated. But my archive is quite well integrated. So I know a lot about who created the collection, when it was created, and I know exactly how many times it's been used, searched, viewed since that stage. And because it's not a well-designed tiering system, these two things live as silos very separate from one another at my institution. That's where it gets really cold really fast. And so that lack of toolkit around the data, we see as a strong signal that part of it didn't work. So, but that integration across the tiers of your active data, your archive, however you want to call it, what's the terminology, but that toolkit, if your toolkit gives you the good information across the system, we do see that working. And so Fabian's example is a really good one, writ large, that can work, but it takes a lot of systems integration work to take the pain out of the user input, which we also have got an opinion on that mandatory fields are useless and don't really work, and machines should do most of that.
Anybody else in the audience that running at the institutional level considering that?
Good morning. I'm Matt Chandler with Princeton University. Spoke yesterday, Fabian mentioned it. We're building a system, we call it Tiger Data. We have to brand it according to our mascot at the university, but it is an institution level system that's going to require data management for all storage. We're rolling it out with some early adopter researchers. Eventually, we'll expand it to the entire university, across domains, all researchers. And after that, we're going to roll it out to administrative data as well. So there's buy-in from the central administration to take a data management approach for all institutional data, meaning everything's going to have metadata. We're going to be able to track everything, organize it centrally, move it across tiers through one data management system. There's a lot of technicalities to that. There's a lot that I'm still working out. So I'm speaking because I'm hoping people will come and talk to me. If you're also working at an institutional level, I want to know more. I want to learn from your experiences.
Thanks, very interesting. Anybody else? Mark?
From my side, it is a little bit different because I'm not from an institutional level perspective, but more from a national perspective. SURF is a national organization. We provide archiving facilities, HPC computing, cloud computing, all kinds of stuff. But the users which we serve are not directly linked to us as an organization, but they get access to our resources by grants. And that is temporarily. And so for us, it was more to see, okay, how are the policies beyond the grant? What do you need to do beyond you have access to our services? And then you go more towards, okay, who's going to pay? But also, what are the policies around this? Because in the Netherlands, mostly what is granted is the active research. But if you want to maintain the data for at least 10 years, then the funding agency is not going to pay for this. So then you go to the institutional level that they want to pay. But the institution is not directly part of the process of getting the grant, doing the active research. So therefore, we see a challenge to maintain this. And we have those kinds of infrastructures. But for certainly, if you look at many of the users who make use of our HPC system, they do not think about the metadata or publish the data because you're more in the practice of doing the analysis. So our systems are not yet that far to tightly integrate with the metadata with our services. We also, for example, use Yoda for part of our institutions, which make use of this, but that is always on basis of contracts. And the institutions are more looking into, okay, this is what we want to use for our researchers, but this indirectly provided by us.
Okay, thanks. I'd like to move on a bit in the discussion. I think one of the things that came up also in Luke's presentations and Fabian's, and it's come up several times now as we're talking about this, is whose responsibility is it? Who's going to be taking the lead on this? Who's going to be hitting that button, or who's going to be triggering that conversation within your institution? I'm intrigued. Is that the same everywhere? Is there variation there? So, Luke, do you want to reflect why you picked this up?
I'll say, just to get the conversation started with the colleagues in the room again, but we're seeing a change at our institution. Cyber's making a big difference. So the conversation has shifted from a single data custodian, which is where we were heading, to now the CIO or cyber leads and the governance process of the university possibly having a cyber responsibility over research data. And so it's looking to be a more split or blended role with retention and most of those data activities done by one data custodian, but other important data actions having to be split across a couple of roles.
And okay, yep. Reese at the back.
Good.
Oh,
First.
okay, and then Vila.
G'day. I just wanted to say 15 years ago, we didn't have this problem. The reason was all the data was hidden under desks. What's actually happened is, as it's got bigger and harder to do, and we want to do it better, we've drawn that data out into managed services. And now for the first time, we can actually see it. And that's why this problem's now in front of us. But just looking at managing costs, it's not the volume of storage, it's the number of objects. We don't have good counting yet on the number of objects in Australia. We have good counting or better counting on the volume. But Melbourne Uni reported to us 4 billion objects in their archive. If you spent 1 second on each, that's 555 people working full time for a year. We're never going to do that. So what we know is we're keeping uncurated data. And I think everyone in this room would say it can't be valuable unless we can curate it. So how do we curate this data, to me, is the real challenge.
Okay, I think Vila was next.
Yes, yes, thanks. About these responsibilities, this is very good question. In Helsinki, we have a quite long tradition for this kind of data support service made by research administration, research university library, and IT center. And it's this kind of collaboration organization. And earlier, this kind of responsibilities with funding made this way that all these units was responsible for some parts of the whole picture. And well, funding comes or not comes from the smaller units and so on. But with this long-term storing project, we have created the model that funding comes straight to the university. It's a higher level, and it comes from the rector, and it's this kind of all those units are not depending on this funding, or we can create the service without this kind of politics discussion with the different units and so on. This leads also the responsibility that leading responsibility goes to the research administration, actually. And then there is we are trying to apply FIT-SM service management model, where is the service owner is a research administration, and then there is a process owners in library and IT center who are creating the services for the whole university, and the money comes from the rector, and we are reporting to the top level. So this makes possible to have this 15 years period, and so I believe, but okay, we will see after 15 years, but I'm retired then, so that's good to me.
Okay, I think we have one question at the back there, and then I think we might need to move to discuss sort of a bit of a wrap up. Yeah.
So this is a question actually also to the audience. Another dimension one could look at is whether the data is created at dedicated instruments in your institution, and whether your institution has a kind of policy that it differentiates between the scientific data that is created essentially at the instrument and is raw data from the instrument, and there is a policy how to deal with that data and retention there, and the difference towards data that has been already touched by somebody else. that is enriched data. So are there any practitioners here in the room who have at their institution this difference in data handling and policy between the instrument data and the scientific post-instrument data? If so, I would be very interested in hearing from you and perhaps also meeting you afterwards.
Immediate responses to that.
Great, thank you. Any other? So I think we've had a reasonable discussion covering a bit of the breadth of the topics. One thing we've not touched on here is disciplinary community. So what, if you're working at that institutional level, what would you like from the discipline? What would be helpful? Is there something there that would make your life easier? Luke?
Take my data and keep it. I mean, that's so we've described this in a couple of papers. This what for mental model's sake, we've called green space the institutions and pink space the communities and disciplines. And this transfer, now a lot of the disciplines are based at universities, and so, you know, take that for what it is. But the role of commons, discipline toolkits and discipline repositories, where the data and the compute and the community are working together, that's probably where the long-term holdings of some data deserve to be. And so for those communities to be established with the right data preservation rules from the start as they mature, we see, I think we see the best decision-making probably happening in the communities as they're emerging, and the worst decisions still being made by the institutions. I'm being provocative and I'd love the conversation.
Yeah, I think so. I'm Stefan Hachinger from LRZ, Leibniz Supercomputing Center in Garching. So I see the retention and disposal maybe not so community dependent after all. I mean, it's good if the communities come with their own guidelines for that, and that's probably desirable. But there's one exception to this not dependence on the community, and that is probably high energy physics or like large scale radio telescopes and so on, where the communities have really to devise a policy on what to throw away because their data volumes are just too high. And I see some efforts going in that way. Yeah, so these should especially come with policies. To the others, we can probably just recommend keep as much as you can.
I think Mark's got a hand up. Yeah.
We are more a generic service provider, I think, somewhere at your side from the institute. We don't know what the content of the data is. So for me, what the community is okay, can you curate the data? Because they have the expertise to be able to curate. We are not. So that for me would be the added value of the community. And also already said, the curation effort probably will, in time, will be the highest cost, not just storing, the creating of the data.
Okay, so looking at this discussion and hearing these things, it sounds like there's a lot of institutions puzzling about the same problem and having to deal with the same problem. Is there anything that would be useful to learn from another institution? You go, that would make my life a lot easier. Noting that there will be variations between institutions, but what is the stuff that would really make your life easier? Or is everybody just going to have to go out and deal with this struggle on their own?
Yeah, so for me, as we are pretty much at zero, basically, and we are just also the compute provider, so we cannot influence all of that. Munich universities will do most of the policies. But it would be really helpful to see in retention systems, in long-term archival systems and so on, what is the percentage of really good metadata with the data, and how you make that grow, because I can say at our institute probably, or at the data stored at our institute is probably like maybe 10% of the archive data are with good metadata, or maybe 1%. And does somebody have more, and how did you achieve that? And how did you measure that? Yeah, that would be really cool to see such statistics or paper on that.
I was about to say, I bet there's a hand going up. Well, there's Reese at the very back, but also a hand here at the front. So yeah, let's do that. So Reese first at the back. Okay. Yeah.
I think we're having a lot of fun counting stuff and discovering things we don't know. So one of our New Zealand universities counted the number of files that had data types that were standard instrument data types, came to 15% of their archive. The majority of the rest was PDFs. But if you don't look and if you don't count, you'll never know.
Thank you. I'm Jitka from the Technical University of Denmark. So what we would like to see is good examples. You know, how do you solve it? You just tell us it. So for example, with the Tiger project, the gentleman, you know, it would just be wonderful just to see what you're doing. We had a meeting with University of Queensland, the RDM system there, that they have. My manager, he said, yeah, let's just buy that one. All right. So if you can provide these examples to our management, the university heads, you know, it's much easier for them to see it, because, you know, I'm just at the library, and how can we develop something with just 3 persons? Then they're knocking on the door of the IT department. So we have to agree on a lot of stuff, right? So just to have the examples, what kind of infrastructure, what tools, what decisions have you taken? That would be wonderful. Share it, please. Make it fair.
Second that.
Luke.
It kind of does feel like we're getting to that level of maturity where some best practice should be more highlighted and more recognized and more promoted in our wider community. It feels like in IT land, you read your Gartner report and you have your sort of your magic quadrant with best of breed over here, when we're probably not doing that in data management land sort of well enough to say best of breed be here, here are a few of combination of vendors or universities that have done a really good job, and whether it's an award system or a process like RDA to really look at some metrics for what might determine the best of breed, but also then say promotion activities around some of those.
For me, it would be more to have more examples of the policies. From a technical side, I think we have some experience already for doing this for many years. But on the policy side, because we are more coming from the technical side, the policy side is for us more lacking. So what do you need on a policy? How do you make those kinds of agreements also with the funding agencies of what they demand? Because I think the funding agencies or the institutes are better suited to define those policies. Certainly, if you look at the national level, then the funding agencies, because they have the money, they will grant the money. And if they set the policies, then we can apply that those policies are being set, instead of that we have to invent those policies by ourselves. So for me, it will be more interesting to see what kind of policy do you have set from an institutional level and from a national level.
Might also be interesting to see which comes first. We have a policy at UCL, but we don't have a way of implementing it yet. So we know what we want, the ideal world. We don't know actually how it works in practice, but certainly, yeah. But pooling the information is something that I'm picking up here, that if we all just share the information better, it'll give everyone a little bit more confidence about how to get started.
While policies are definitely very important, there's also no lack of very vague policies. And if we look at the relationship between the data owners and the ones who will finally make the decision what to throw away and to be liable for this decision in the future, there's a large gap in between those. So you either have instruments to encourage people to make those decisions. For example, I found it very interesting that there's a distinction between an active storage system, and at some point you moved your data to another system, and then you're bound to new rules that have been agreed upon beforehand. But if there is nothing like this, you will always come to a kind of deadlock where the data owners will say, oh yeah, of course, we will listen to these policies, but please provide us with additional funding for this. And then you will have the deadlock between I'm responsible for the data and you want me to do something with the data, but you don't give me additional funding. And it's very difficult to get out of this because in the end, nobody wants to be the person responsible for deleting valuable data, even if it's just hypothetical, but management and scientific management as well is pretty risk averse.
These policies are, they are quite hard bite. And in Helsinki, we have discussed now, wait a second, almost 11 months about policies, how to move or share responsibilities between units and between researchers, who owns the data and what kind of ownership model we will have. We will have the model where we have to share this ownership between researchers and university if researchers would like to store data in our long-term solution and so on. We have to do this kind of service provider style implementation because we can't negotiate with about these things with every research groups and so on. I think in the future, the hardest bites will be actually research data value assessment, which we have outsourced from the project because we understood that it's something what we are not able to do. But in the future, we have to give guidelines to faculties that, okay, what kind of value data include and how to assess this value and what they have to do and so on. I believe that this will be the very, very hard bite in the future, but we will see what is the practice with that also.
Okay. Is there one final question, and then we'll comment, and then we'll wrap it up.
Thanks. Very quick one, just inspired by all the discussions. I feel in terms of policy and implementation, maybe even costing, I feel there are a lot of gaps in the current practices or institutions. One question we were really puzzled is because now it seems like you have a lot of data, large size. Okay, let's get more storage. So and there's a cost for storage, but it's not well calculated. So we don't know the price of the storage. We just keep telling researchers, we're gonna store your data and we're gonna keep it long term. But then eventually, should it be always the case like, okay, more resources, more funding, more storage, and then keep going? Or we should, I don't know how to change or anything need to be changed. So I feel that's definitely policy discussion. How should we give space to researcher to research project and how to support that? So it's kind of an open question to all. I wonder if that's relevant.
Okay, so thank you all for your contributions. It's been a wide-ranging discussion. I think, thank you also to our great speakers. I think Luke and Fabian gave us a great introduction and a quite nice mix of perspectives that showed the different considerations that you need to tackle. It sounds like it's a shared pain. I heard a lot of pain around the room, which is always lovely to share pain. I especially love that perspective of a beached data. Was it stranded data? I almost imagine this beached whale lying there on the beach, rotting away, and you're thinking, oh dear, this is so huge. How do you chop it up? Yes, you can chop it up into lots and lots and lots of different little elements, but they all need to be curated. It's a lot of work and it's a lot of pain. So how do we as an institution deal with that? And it sounds like it's not just one person in the institution, but it sounds like different people need to be involved. It's very interesting to hear the different drivers in different countries. The policies differ to a certain extent, and how to meet those, the challenges of cyber that are coming in there, the challenges of privacy in Europe especially coming in there. So there are slight different nuances there, but I think in general, everybody's sharing the pain. So it's wonderful to hear this discussion. Please come up to the front if you're interested in continuing this discussion, and especially hearing about Tiger. That sounded really interesting too. So seeing what you're doing there and how the Tiger is going to attack this big challenge and bite off a chunk. I think one of the challenges there is that question of data debris versus data? And when does debris become data? And how do you document that? And where do you capture that information so you can make decisions, and leave preferably automated decisions too, because that would make life easier. But maybe that's just a little hopeful at this point. So thank you all. Thank you all for that contribution to that discussion. I think it was really interesting to hear all your thoughts. The group, the interest group is continuing as usual, and every time we pick off different topics. The next plenary, I understand, will probably be a virtual plenary. I've not heard the date yet. We have been thinking around on a session at the next plenary, and we're looking at research data architectures in research institutions in the Global South. So what are the challenges that are happening there, and what are specific challenges in that space? So we're looking to prepare a session there. If you're interested in either contributing, if you have a speaker, or if you'd like to play a role in facilitating that discussion, we'd love to hear from you. So either come up to the front or shoot us an email, and we'd love to discuss what that might look like and what we could have in the way of speakers at that session. That was it for me. James, Rory?
I don't think I've got anything to add really, but it does seem that based on the conversation, there's quite a lot of interest in some sharing sort of emerging good practice in this kind of field and just generating greater awareness of what's going on. So if there is interest in maybe spinning out a different group or something, then we might have, people might want to take a bit more of a sort of a leadership position in bringing some of these ideas forward. I, for one, would certainly be very interested to hear more about that. So as a community, if we want to get involved in maybe following up on some of the conversations we've had in some way, drop us a line, and maybe we might think of spinning something out. I think we've had a lot of ideas which potentially be taken forward from this session, which doesn't always happen. Sometimes we just have a nice conversation and people exchange ideas, but maybe there's ways in which we could take things forward a little bit from here.
Okay. Rory, any thoughts? No. Okay, thank you. Well, in that case, I would like to thank you all for your time. Thank you all for your contributions. It was very interesting, and I hope you come out of this also with a bit of a positive feel and not just the pain of lots and lots of data lying around. Thank you all.